Hello everyone, this one is our last topic of a PDE, application to partial differential equation. First application is to the wave equation. Okay, and the other two will be one-dimensional heat flow and two-dimensional heat flow. So we'll see in this session only the wave equation, how to find the solution of a wave equation. So for this wave equation, the first thing I will show you one diagram here, then it becomes more clear. So suppose we have a string. We have a string which is stretched between 2 points. So let us assume this initial point is x equal to 0 and this is x is equal to l. So what is this actually? So the distance from x equal to 0 for this string is stretched at two endpoints at distance 0 and l there. So the string is fixed there. There is no displacement at these 2 points. Then we have our aim is to find out u of xt. What is this u of xt? U of xt is a displacement function. So it is our complete aim here in differential equation. By solving the differential equation, we are going to find out the function u of xt, which represents a displacement of a string or the motion of a string at a distance x. So this x is a distance, means say suppose this is some point, say at any point x. Okay, at this point. So x is a distance from 0 only. So this is the length of so at this point, what is that displacement of the string, that we are going to find out, and at a time t. So x is the distance, t is a time. So these are the two variables that we have. This is a function of two variable u of xt, and u represents the displacement or the displacement of the string at distance x, and a time t. Okay, that is our aim. But you'll observe, as the string is fixed at both the end, there are these four important conditions known as a boundary condition and initial condition. They are always in the wave equation. Okay, what are the boundary condition? Remember, x is for the first variable is a displacement, and the second or first is a distance. My mistake. First is the x is a distance and t is a time. X is a distance from 0 and t is a time. So the boundary conditions are nothing but, you'll observe, at both the end the displacement is a 0. So whenever we have x as a 0 at any time t, and when x is a 0, displacement is a 0, because that is a fixed point. Exactly same thing, u of lt is also 0. Why u of lt is a 0? Because when x is a l, l is a fixed there, means at that end point again there is no displacement, so that is a 0. So this condition is known as a boundary condition. So there are two boundary conditions always. Not only that, we have initial conditions. Now we have for any x can be anything. Okay, at any x, but time is a 0. Time is 0. So as time is a 0, means initial time, so it is known as initial condition. So initial time, we are given some fx. What is this? So we say at a point x, we are going to give this as a displacement, initial displacement. This is the initial displacement. And then ut of x0, ut means actually this is a dou u by dou t. As u is a function of x and t, we can calculate dou u by dou t. Now rate of change of this displacement, u is a displacement, t is a time, rate of change of displacement is a velocity, dou u by dou t is a velocity. So this is known as the initial velocity. Why initial velocity? Because we are writing dou u by dou t at t equal to 0. So that is also given, initial velocity will be given to the string, and that is assumed as a gx. So these two are the initial condition, and this one is the boundary condition. So they are always there. Now this is just information about the motion of a string or vibration. Okay, we are studying here the vibration of the stretched string. Okay, vibrations of the stretched string. So what, where you should focus now? Remember, which are the important things that you have to remember? There are two important equations you should remember in the wave equation. The first one is the wave equation. The wave equation is given by this form: dou 2u by dou t square equal to c square dou 2u by dou x square. Now, this c square is some constant that appears in the wave equation. Sometimes that c square may be replaced by a square, may be replaced by k square. Anything can be there. Okay, anything, anything. In particular, it may be given 9 also, like c square equal to 9 or c square is equal to 100. Okay, so it can be any constant, but generally it is general constant. So uh, with this boundary condition and initial condition, yes, they are always there, that given in the question itself. So you should not, no need to by heart it, you will get it. But this one is one more equation that you have to remember, that is known as a general solution of the vibration of string, or general solution of the wave equation. Why this is a general solution? You will observe u of xt represents displacement at a distance x and a time t, where that displacement depends on the variable x and the variable t both. This c1, c2, c3, c4, they are arbitrary constant. Not only that, m is also the arbitrary constant. Okay, so there are 5 arbitrary constant, and this c is not arbitrary constant. In between, the c1 is the cos cmt is there, and sin cmt. This c is appeared from this, from here, that c square. Suppose in the equation there is a square, you should write c3 cos amt plus c4 sin amt. Same thing for k square. Suppose k square is there, cos kmt and sin kmt should be there. So this is one important equation you have to remember, and this is other equation. So wave equation is given by dou 2u by dou t square is equal to c square dou 2u by dou x square. The derivation of the wave equation is there in the textbook. If you want, yes, you can go through that. Similarly, the derivation of this general solution, which is based on the complementary function of LDE, is there in the textbook. If you want, you can go through that. So, but I suggest these are the standard derivations, and that generally doesn't comes in the exam. So you should remember this. Okay. Now, if that is the case, what is our aim? Our aim is to get in the example this displacement function only u of xt, where we are going to find out the values of c1, c2, c3, c4, and the constant m. So there are total 5 constant whose value we are going to find out by using 4 conditions: 1, 2, 3, and 4. So only 4 conditions and 5 constant. Yes, it is possible. We'll see with example only. Come to the example here. So the questions will be like this in the exam. Remember, these examples are coming for 10 marks. One example, 10 marks. Reason is only these are lengthy examples. These are lengthy examples. So if it comes, it will come for 10 marks only. So we have a first example on the wave equation like this. We are given a wave equation. You will observe whatever the equation we are given here, this is a wave equation only. Okay, only that c square is replaced by a square there. So accordingly, we have to select our general solution. So whenever you are given a wave equation, you can start your solution by a general solution. Okay, we know that. We know that general solution, general solution of wave equation is u of xt, u of xt is equal to c1 cos mx plus c2 sin mx into c3 cos, there is a cmt, but instead of c now we should use this a, c3 cos amt plus c4 sin amt. So this will be our equation 1. We got a general solution of displacement u of xt. Okay, but there are four important conditions that always given in the question. So two of them always there, because in the wave equation boundaries are always fixed. So at the boundary the displacements are zero. So I will write these four conditions here. But the first condition, u of 0t is 0, that I will equation 2. U of lt is also 0, that is equation 3. Okay, equation 2 is the uh, this is a displacement at x equal to 0, that is 0. Displacement at x equal to l is also 0, means at both the end of the string, both the end of the string at x equal to 0 and at x equal to l, the string is fixed. It is fixed. It cannot move. There is zero displacement. So u is a 0, u is a displacement, that is a 0. But remaining two are generally the different that you have to find out from the question itself. We are given initially the shape is given as lx minus x square. Initially it takes the shape of lx minus x square. So the shape may look like this. This is the dotted graph I am drawing. So this is the means it is stretched like this. The string is stretched at up to this point, and it takes the shape of like a parabola, lx minus x square. Initially means at t equal to 0. When t is 0 and any x, at any x it is stretched. So the next condition is u of x0. Initially it takes the shape of a parabola in the form of lx minus x square. So that is condition number 4. So 2, 3, 4, these are three conditions we taken. Last condition is given there, that the string is released from rest, means just it is stretched and released. So no extra initial velocity is given. No initial velocity is given. So last and fourth condition that we should have that as, which is the fifth condition, ut of x0 is 0. So this is I give as equation 5. So remember, the ultimate aim of all the examples of the application of PDE is use a general solution and the initial and boundary condition and find the particular solution. From the general, just we have to find out particular solution, but it is lengthy. Okay, you have to apply these conditions one by one, and there is always one sequence. The sequence, yes, we should apply the first condition only first, which is a u of 0t is a 0. Remember, you can apply these conditions in any order, but in some orders it calculation becomes little lengthy. So you should remember the sequence also. So let me see the equation 1 and equation 2. So I will write it here in the next line, by 1 and 2, by 1 and 2. What is 1? What is 2? U of 0t is 0. Now this u of t is u of 0t is a 0, means when x is a 0, u is a 0. So let me replace x by 0 in the equation 1 only. Here is equation 1. So we are replacing x by 0. When we replace x by 0, there will be change in the first bracket only here. Cos 0, cos 0 is 1. Sin 0 is a 0. So what we left? We left with cos 0 is 1. So it is, we left with C1 only from the first bracket. And remaining we left as a C3 cos of AMT plus C4 sin of AMT. So that about this that about the replacement. Now what is our aim? Our aim is to get the values of Ci, that constant C1, C2, C3, C4. So if you observe this equation carefully, we have the multiplication of this C1 and the multiplication of this bracket is 0. 0 is equal to C1 into this bracket. Now it is the situation like multiplication of two factors is a 0, like a into b is a 0. We know the product ab is a 0 only if either a is a 0 or b is a 0 or both are 0. So which term should be 0 now? If you consider this bracket is a 0, it's not possible. Why it is not possible? Remember, this bracket is this entire equation we return for any value of t. This is for all values of t. So t is not fixed here. So for all values of t, displacement cannot be 0. Okay. So this bracket cannot be 0 because this bracket involves the variable t. The first term c1 is free from variable. It is just constant. So constant should be 0. So this gives us c1 is a 0. So this is the important thing that we received. We got the value of one of the constant in the general solution. So the general solution 1 becomes. Therefore, solution 1 becomes. Now we are going to replace c1 by 0 in the solution 1. So it becomes u of x comma t, u of x comma t. Now remember that c1 is a 0. You'll observe that equation 1 first here. So this c1 is a 0. Only c2 sine mx will left and this bracket as it is. So we come across c2 sine of mx into c3 cos of amt plus c4 sine of amt. T is there. Okay. So that is the general solution. You'll observe now in general solution we'll have with C2, C3, C4 and M. But remember here is one hint and that you should do it. Without that you cannot get a value of all the constant. You can merge one more constant here. This C2. This C2 can be multiplied inside the bracket and we can get the general solution as this sine mx outside as it is, and when I take C2 inside it becomes C2 into C3, that I can write it as a C5 new constant cos amt. Same thing C2 into C4 I can write like a new constant as a C6 sine of amt, and that's one. You will observe one more constant we reduce. So if you want, if you don't understand, you can write also C5 is C2 C3, C6 is C2 C4 that way. Okay, so in this way we get a new solution. Actually solution 1 converted to how many conditions? 5 equations we given. Yes, it is a sixth equation. Now I will give this as u of xt as equation number 6. So actually that equation is, just a minute, this is the equation 6. Okay, now we have equation 6 is reduced solution after one boundary condition. Remember, when you apply one boundary condition, you should apply another condition, which is actually the initial velocity that we have to apply to get the new constant. So next condition that we are going to apply it is condition number 5. This condition 5, ut of x0 is 0. So now by 5 and 6, by equation 5 and 6. Let I write first equation 5. Equation 5 is ut of x0 is 0. But now from 6 we have to write down ut. What is ut? Ut is a dou u by dou t. You have to write down dou u by dou t. At the same time, you have to replace t by 0. We'll replace t by 0 later on. Just let me find out dou u by dou t of equation 6. Partial differentiation of equation 6 with respect to t. So as we are differentiating with t, sine mx is a constant as it is because differentiation is with a t variable. Sine mx as it is. Derivative of c5 cos amt. So c5 is a constant. Derivative of cos is a minus sign. So minus c5 sine amt into am plus c6 derivative of sine become cos amt into am, and that's one where we have to replace t is a 0. So indirectly we got 0 is equal to sin mx will be as it is. Sin mx will be as it is. Now see, t is a 0. So when t is a 0, sin 0 is a 0. This term, sin 0 is a 0. Cos 0 is 1. So what we left? We left with this term is a 0. We left with a c6 into am. This am. Okay. Cos 0 is 1. Cos 0 is 1. Now again we come across one situation here where the multiplication of sin mx, c6 and am, these three is a 0. So at least one of them should be 0. Remember, these are am is a general constant. So actually the this am is a coefficient there. That coefficient cannot be 0. Mainly sin mx, again this x is involved, so x is a variable. So for all values of x, sin mx cannot be 0. Sin mx cannot be 0, but yes, c6 should be 0. So this gives us, these are standard solution, and each and every example of wave equation you will come across same situation, similar answer. So this gives us this gives us c6 as a 0. C6 should be 0. So this is another important value we got it. Initially we got C1 as a 0. Is that? C1 is a 0. You will observe this C1 is a 0. Now we got C6 as a 0. So see, the solution becomes simple and simple now, and that becomes more particular now. It becomes with, so two conditions we applied. So let me replace C6 by 0 in equation 6. So by equation 6 then u of xt will become sin mx as it is, and c5 cos amt, there. Okay, c5 cos, c6 is a 0. So cos of amt. So that is the equation number 7. So see, the initially our solution is equation 1. That equation 1 we converted to the equation 6. Now equation 6 is converted to the solution 7 now. So in solution 7, c5, still c5 is unknown to us, and the value of m is unknown to us. These two constants are still left to evaluate, and for that we have two more conditions known as one more boundary condition is left, which is u of lt, and the last, that is initial displacement. So let me apply the third condition, which is a boundary condition. So I think that is equation number u of lt is a 0. U of lt 0 is a condition 3 only. Okay, u of lt. So by condition 3 and 7, by sorry by 3 and 7, by 3 and 7, u of lt is a 0. So that x should be replaced by l. So we get sin ml c5 cos amt. Sorry, my mistake. I think u of lt. Yes, we are correct. Cos of amt. Cos of amt. My mistake. Now we come across again the similar case where sin ml into c5 into cos amt should be 0. Okay, that is 0. That is 0 given. So now which should be 0? Yes, we can take c5 0, which is a general constant. But if you take c5 0, now you come to the equation 7, you will observe u of xt complete becomes 0. Means we get a trivial solution. 0 solution is always a trivial solution of any differential equation. So you can say 0 is a solution of all the differential equation, majority of that. Okay. But we are interested in non-trivial solution. For non-trivial solution, C5 cannot be 0. If C5 is not 0, cos AMT, it also cannot be 0 because it involves the variable t. What about then last sin ml? Yes, Sine ml should be 0 because there is no variable in this term. So the next step, this gives us sine of ml, sine of m into l should be 0. But if you recall the property, sine theta is a 0, then theta is n pi. Sine theta is a 0, then theta should be n pi. So m into l should be n into pi, because integer multiple of pi, then sine is a 0. That you already learnt in Fourier series also. Number of times you replace the values of sines as a 0 there. So what is the value of m? The value of m we get, n pi by l. So this is the third constant we got. Initially we got C1, then we got that C6. Now we got m as n pi by l. Okay. So, but what is this n? N is an integer. For integer multiple of a pi, sine theta is a 0. Sine theta is 0, then theta can be 0, theta can be 1 pi, theta can be 2 pi, 3 pi. So in general, ml is a theta here. Ml is equal to n pi. So where what is n? N takes the values 1, 2, 3 and so on. So integer multiple there. So when we replace this value of m in the equation 7, so therefore solution 7 become, therefore by 7 we can say u of xt will become, u of xt will become, we replace m as n pi x by l, sine of n pi x by l, c5 as it is, cos of a n pi t by l. Okay, but remember this is solution for each value of n. So sum of all that is also the solution. N varies from 1 to infinity. So this is the equation number 8 we get. Almost we completed our solution, but still it is not the end. There is one more condition left, which is a initial displacement. Initial displacement is left. That is condition number, this is condition number 4. Condition number 4 is yet we not applied. Okay, and what is the use of condition number 4? To get the value of this C5. We are going to calculate C5 now. To calculate a C5, we use that condition number 4. So the last part is left, and you will observe now something you learned like this, and that is the half range sine series. Okay, you will get come to that. Okay, let me first apply that condition. You will get it. So by 4 and 8, let I check whether it is a condition 4 only. Yes, condition 4. U of x0 is lx minus x square. So that is only the non-zero condition always we have. So that is a condition 4. Remember, the non-zero condition only we apply at the end always. So by 4 and 8, by 4, equation 4 and 8. Okay. What is 4? 4 is u of, now x, I think, yes, x will be as it is, but t should be 0. U of x0 is lx minus x square, which is, now we are going to replace this t by 0 in the equation 8. If you replace in the equation 8, what happens? N varies from 1 to infinity. Let I write C5 first. C5 sine n pi x by l, sine n pi x by l, and remember t is a 0 and cos 0 is a 1. Cos 0 is 1. So we come to this equation. Now this is a very important now. This is very, very important. You will observe whatever the equation we got here, this equation is, if you correlate this with whatever you learned, that I am saying actually be in the beginning, and now yes, you should be good in the half range Fourier series. Always you require generally half range sine series only. So you'll observe this is like fx, function of x. This is like f of x. F of x is equal to summation bn sine n pi x by l. Fx is equal to summation bn sine n pi x by l. So this is a half range sine series. So how to get the value of C5? By half range Fourier sine formula. So you can write here also, which is half range sine series Therefore, the value of C5, this is like a value formula for Bn, formula of Bn of half range sine series. What is the formula of Bn in the half range sine series? It is a 2 by L. Let I write general formula first. 2 by L integration 0 to L fx sine n pi x by L dx. Now what is L in this case? What is L in this case? The value of L, that if you see at the beginning only, this L is the length of the string. L is the length of 0 to L we are given. So yes, 0 to L only. So that is L only. So L is itself L here. Okay, so the same L, because in half range series we compare 0 to L with 0 to L only. So we get L is L only. Okay, so there will not be a change. What is fx? Fx is this Lx minus x square. That's one only. So we got C5 here. Instead of Bn only, we written C5 there. So this 2 by 5 as it is, sorry, 2 by L as it is, integral 0 to L. Now fx is Lx minus x square sine of n pi x upon L dx. And which method we require now? Which method we should require to integrate Lx minus x square into sine? So obviously the first one is a u and the other one is a v, and we use a generalized by part, the most important generalized by part of the Fourier series. Remember, the purpose of a Fourier series only, or the origin of a Fourier series only, this heat equation and wave equation. While solving heat and wave equation, Fourier introduce this Fourier series only. Okay, so that is a application of a Fourier series, you can say. And now if we apply the generalized by part, we get the value of C5, and when we replace this C5 in this equation, equation 8, that is the end of the question then. So that much of the part you have to do it for the 10-mark question. So let me find out this C5. So here, let I come to the calculation. So 2 by L as it is, u is Lx minus x square, v1 integration of sine is a minus cos n pi x upon L divided by n pi by L. This is u v1 minus u dash. U dash is L minus 2x, Lx minus x square derivative, L minus 2x. V2 integration of minus cos is a minus sine n pi x by L upon n square pi square by L square. So that about u v1 minus u dash v2 plus u double dash. Now derivative of L minus 2x is a minus 2, and integration of minus sign, it become plus cos n pi x upon L upon n cube pi cube upon L cube. That's one, and the limits 0 to L. So as usual, when we replace this x by L, when we replace x by so before that, when we replace x by L or x by 0, the term of sign always goes to the 0. So this term go to the 0. This will be 0 for upper and lower limit both, because integer multiple of sign is a 0. When we replace upper limit L, you get L square minus L square. This first term is a 0. So only that second term will preserve there when we replace this x by L. So 2 by L as it is. The first term, this is a 0. When we replace L here, this is minus 2. Now remember, you are replacing x by L. L gets cancelled. Cos n pi minus 1 raised to n L cube upon n cube pi cube. So this is for upper limit x by L. Now when we replace x by 0, again Lx minus x square, this term goes to the 0 only. This is a 0 only. But lower limit of the minus sign, that minus minus become plus 2. Plus 2. Cos 0 is 1, and that is a L cube upon n cube pi cube. Let me simplify to get the value of C5. So you will observe that L cube comes common, one of the L will get cancelled. So this 2 is a common, 2 into 2 is a 4. Okay, 2 is a common, 2 into 2 is a 4. L square will be a common, one of the L got cancelled. N cube pi cube is also common, n cube pi cube is also the common, and we left with 1 minus minus 1 raised to n in the bracket. So this is the value of C5. This is the last constant we have to determine, and that we got it. So therefore solution 8 become, therefore by equation 8 we have the final answer, which is a u of xt is equal to summation n varies from 1 to infinity. The value of C5, I will write it first, 4l square upon n cube pi cube into 1 minus minus 1 raised to n. Now there is a, if you observe in the equation 8, we written C5 first. Now sin n pi x by l and cos n pi at by l. Sin n pi x by l into sine of, just a minute, I will erase this unwanted, into sine n pi x by l into cos of n pi at upon l. So this is the final answer that we got here, and this final answer, yes, you can highlight. Okay, that's one. So that about the end of the question, 10-mark question, where what is this final answer, that equation 8 we converted is the displacement of the string. This is the displacement of the string at a distance x at a time t, and with that four conditions, two of them are boundary and two of them are initial condition, and we got that solution. Okay, so that about the way or the method to solve the differential equation, wave equation here. Remember, in every wave equation you have to do the same thing. For example, if I show you one more question, a quick question, I will not go in the complete solution. Let I come to that question first. So here is the question 2. The question 2, remember the three conditions are always same, means up to which equation you have to do the same. Remember, your calculation will go up to this equation number 8. Okay, up to equation 8 you have to do the same thing, only this u of x0 will be the different, u of x0 will be a different, and then you can do it. So in equation, for example, here is the question number 2 is there. You observe the question. The question is this one. A string is stretched and fastened to 2 points L apart. Motion is started by displacing the string. So this is like the initial displacement. Initial displacement is given here at t equal to 0. And yes, the differential equation is also given where the wave equation A is used. So same A. So just like a previous question only. So you have to do the same calculation, because the initial only that u of x0, this u of x0 is this one. This is condition number 4. That is always a different only. So and from there you have different 4 years. Okay, different way only. Okay, let me come to that part only. So just like in a previous question, you should find out first. Equation 8, which is a u of xt. U of xt is a summation n varies from 1 to infinity c5 cos n pi x upon l. Is it cos or sine? Let I check. Sine, I think. Sine n pi x by l cos n pi at by l. Sine, this is a sine n pi x by l into cos n pi at upon l. So this is the equation 8, and that you should come to the equation 8 exactly same way whatever we done in the previous question. So up to here, every time in the wave equation you have to do the similar thing. because 99% of the time you have the same boundary conditions. Obviously the boundary conditions will never change, but initial condition can change. If dou u by dou t is a change, this equation 8 can change, but always that is generally the same. The last condition which we have to apply, the condition 4. In this case, the condition number 4, is, which is a u of say x0. In the previous is lx minus x square. Here we are given initial velocity is minus a sine pi x by l, minus a sine pi x by l. This is the condition 4. So by this condition and 8, okay, so I'll take this as a condition 4 only, like previous question. So by 4 and 8, by 4 and 8, 4 and 8, minus a sine pi x by l. This is the equation 4, and let me replace t by 0 in the equation 8, which is summation n varies from 1 to infinity c5 sine n pi x by l. Now remember, this is Fourier series, and now half-range Fourier, if you use it and find out C5, you get the same thing. But no need to use a Fourier series also, because you will observe both side are the trigonometry function. So this sine pi x by l and here is sine n pi x by l. So this obviously indicates first thing, this series if you expand, n should be 1, then only you get sine pi x by l, and the C5 should be minus a. C5 should be minus a. So just by comparison we got it. The reason is why by comparison we got it, because if you expand this series, you get say C5 sine pi x by l plus C5 sine 2 pi x by l, C5 sine 3 pi x by l, but there is no term of sine 2 pi x, 3 pi x on the LHS. So obviously by comparing both sides of the equation, we got n and C5 here. This is only one little different question. Otherwise, every time you have to use a half range sine series only. Half range sine series only. So whatever the last case, the final solution of this wave equation only will not come in summation form, because we got n is only 1, all other n's are 0, not coming there in the solution. So u of xt will become minus a sine pi x by l. So therefore solution 8 become by 8 u of xt is, value of c5 is a minus a sine pi x by l into cos pi at upon l. That's one. So this is only a particular solution that we have, and that is the end of the question here. Okay, so that about wave equation. Remember, do just one example, first example, and remember you can solve any example of the wave equation type. Then the reason is every time you have to do the same calculation, only that small condition, last condition will be changed, which is initial displacement u of x0, and depending of u of x0, you have to find out the Fourier coefficient C5 by half range sine series. Okay, so that about your wave equation. Thank you.